Welcome to the homepage of PhET Interactive Simulations, a product of the University of Colorado at Boulder that contains 100 or more interactive computer simulations for science and math. To explore these, just click on Explore Our Sims, and you get a page that can access all 100 of them. Now that may be too many, so I suggest that you click Filter. And there you can specify your subject, grade level, and so on. Locale allows you to specify the language of the sim. There are 40 or more available. Accessibility allows you to configure the sim so that you can meet the needs of disabled students. Compatibility is very important because HTML5 is the format that allows the simulation to run in any web browser. That means that you can use it on any Mac, Windows, Chromebook, or iPad. And grade level, for elementary school, we can see we have 40 sims that we could use. For middle school, 64. For high school, 67. For university, 57. So there is something here for all grade levels. For subjects, it's mostly science subjects, but math is very suitable for upper elementary, also for beginning algebra students. It's a mix of traditional science, such as classic motion physics, all the way up to cutting-edge science, such as the quantum phenomena in quantum physics. Well, to explore one in greater depth, let's pick Energy Skate Park, a particularly popular simulation. Every simulation has its own web page, so this, of course, is where we would initiate the simulation just by clicking in the middle of the image. But for teachers, the About button is very helpful because it shows the science topics that this sim covers and the sample learning goals. And even better is a huge list of lesson plans for this simulation submitted by teachers who've actually used it and by the PhET staff. And here's one for high school. Here's one that is a lesson plan for middle school that's suitable for in-class lab or homework or remote use. So very cool stuff. There's even a PDF of teacher tips for each sim so that you can learn in advance without going through every part. The Embed button allows you to embed this simulation in any web page you control. So you can put it into your teacher web page, into an assignment web page. Students who create their own web pages can create Energy Skate Park right within their page. Notice that since it's a free system and I didn't have to log in, this doesn't need to know the names of your students. Nobody needs an account on this. Kids can download it and use it at home, no cost whatsoever. But let's see it. So I clicked the Go button. Energy Skate Park is now loaded. We have 4 modules, an intro module, a measure module where the numbers and units of science are introduced, a graphs module where we can see the variables change visually, and a playground module, which is probably everyone's favorite. But let's start with intro. So Energy Skate Park, of course, has skateboarders and skateboard tracks. And you can imagine what happens here, but we can see the changes of the skater's kinetic energy and potential energy. We can also see the skater's speed. And we're not stuck with this track. We can try, how about a kind of a Camel's Hump track? Or what kids would love is a loop-de-loop. And we can also change, we can make it a little boy skater. We can change the size, meaning the mass or weight of the skater. So here's suddenly a big boy skater or a really little boy skater. And kids can see, gee, does the weight or mass change the physics of potential and kinetic energy? We can also add friction so we can see thermal energy, and we can change gravity so we could create a skateboard park for the moon or Mars. Let's take a look at measure. Measure gives us a sensor that we can place on a part of the track, and we can see the actual numbers and units of energy, height, and speed. With graphs, we can see those numbers, but in a graphical form. So you can see the yellow line shows that the total energy of the system stays constant, but the kinetic and potential energies vacillate according to the position and speed of the skater. If we look at the playground, we'll see why it's everyone's favorite, because you can create your own skateboard track. So here's a simple one. And we can see our skateboarder, and that's a pretty simple one. So let's make a more complex one. How about a camel's hump? Now let's get our skateboarder starting a little higher and see what happens. Whoa! And as you'd expect, we can see the graph of the energy on our own skateboard track. Now, do you think we can make this even more interesting? Well, let's pause and let's see if we can create a loop-de-loop, because I think a lot of your kids would love this. So kids learn how to do this kind of quickly. It takes a little trial and error. You can use as many skateboard track segments as you want. Okay, and let's put our skateboarder up here and give her the go signal, and away she goes. And what would happen if we make this going on the moon? Why is she going slower? So this is Energy Skate Park. It is lots of fun. It focuses on the specific science topic of kinetic and potential energy with a little bit of thermal energy. Each of the simulations focus on a specific science topic, allows kids to learn by hands-on experiment where they can change the variables, and they get not only an intuitive feel, but you can change the module to display the numeric information for calculations and the graphs for visual understanding. I hope you get to try PhET interactive simulations. I think you and your students will really love them.